Now I'll focus on the case studies. Okay. So after the break, you'll not see anything mathematical. Most of it be common sense. Hopefully all of you had a good cup of tea. And I'll not be focusing so much. See, normally when we talk about the wide area networks, remote sites, now there are standard things you do to hide the communication costs. So two simple things you do is, either you say I'll keep a cache, so I don't have to go to a remote site. Or you say if I have no choice but to go to the remote site, then I should do things in bulk. So I can say rather than go to Umesh 10 times and Umesh sits 100 kilometers away, I'll go to Umesh once and in bulk I'll fetch 20,000 rupees from him. So that is a bulk option. But what I'll focus on is, one is things when we are dealing with these distributed service oriented systems. What do you do when you're dealing with, what are the kind of performance issues you get? Okay. Now I have just categorized into simple areas. One is saying is certain things get impacted because of very high frequency. Okay, so frequency essentially, as I was saying, the visit count is frequency. How do we do frequency management? The other is, which says is, I may manage the frequency, but very often I have some services I've launched is running fine and then there will be interference. Let's have a printing service, it works fine. Everybody is firing 1 page, 2 pages. One fine day somebody fires a book. So then you're driving behind your truck, especially those of you who drive and go on the highway. Sometimes you don't go on Bombay Pune road which has 3 lanes. You may go on a lane, sometimes even in Jogeshwari Link Road, you'll get at least 10 minutes ahead of you there will be a truck. And you just want to overtake that guy. So those are things of interference. How do you deal with it? The other is, it may not be interference because you are also a truck driver. Okay, say interference is you are a car driver and other chap is a truck driver. If you are also a truck driver, then you are saying this, I am dealing with how do I manage a payload. Correct. And the last part I will deal with is not necessarily performance, but from an end user, we often talk about the word performability. Let's say it takes me 10 minutes to get a response. Is it because the site is slow in performing? Or is it because there has been some downtime or there is some availability problem? So that's what I'll just introduce a little bit, just through an example of self-healing systems. All these things are real life case studies I'll talk about. What is there in the industry? Okay, so I'm not trying to be expansive in cover, these are all possible techniques. I'm just saying is what we have experienced predominantly in the Indian industry when we are dealing with large distributed systems, some of which will have service oriented aspects also. Now the reference I've just put in general terms because any kind of system we deal with, there will be remote users, local users, there is a business processing tier. You may either keep a web tier for connection management presentation or you may build your own tier. There will be some database tier, there will be some messaging, external interfaces. Okay, and then whenever problem management, there will be a different kind of setup in the organization. So just keep this in the background. Okay, this is pretty obvious, so I will not go in details of this. Now let's deal with this frequency part. Okay, the transient is, for example, it happens in State Bank of India. There's a whole back-end layer of processing, and to get to the back-end, there's a lot of queues that the load will come in from the queues. However, it is just sometimes that somebody for a very small amount of time may get a delayed response. So what we do in that case is we keep a simple thresholding policy, which means is every queue has a certain limit. If you exceed that limit, then don't allow extra load to come in. Just reject the request. The teller will at the most resubmit it. Okay. Now if the teller resubmits it, we have found the probability of accepting the second time is very high. So there is no need to keep a sophisticated management. These are all controls which you keep for load balancing. So one load balancing is saying is I load balance across extra capacity, extra services. The other is I say I keep a threshold, which I will not accept more load than this threshold, and that manages load perfectly. Okay. Now what also happens is, which I'll come to the next, right? These are things where I have a lot of frequency coming in, a lot of rate coming in, how do I manage? As I said, the other challenge you face very often is, you are going at your own speed and then suddenly you get stuck behind a large truck, there is interference. Now how do you manage interference? Okay. Now other interference we get is not so simple, right? It is not that I can say come end of day, let's say I am going to a bank, please update my passbook, sorry come end of day, that will not be acceptable, correct? So what you do is you may have cases where you start getting like a 100-page printout somewhere in the middle. Now these cases come up very often. So the simple way is there is a lot of queue management where a simple pattern you follow is, instead of keeping a single queue to do all the processing, you break it up into a router and separate queues. Now what happens is, these queues which deal with all the small load, all the one-page printouts, this will finish off pretty quickly. The other one, even if it takes half an hour, that's okay, you asked for it. Correct. So you segregate out, that's how you separate out the interference, by saying it's a separation of concerns, I will not cause it to interfere. Now this is the other area which says is, all of this was interference, okay. Now you talk about interference if one person is a Ferrari driver, one person is a truck driver. Then you say the truck driver is interfering with the Ferrari. Okay, but if everybody is a truck driver, then you can't call it interference. Because, so this was a classic example of, Clearing Corporation of India. So what happens in Clearing Corporation of India is, you get all these banks over the country. Now there are RBI guidelines which says is, every bank has to maintain a minimum cash balance, correct? If you fall short, then you are supposed to borrow from any other bank. So what they do is, they will borrow from, let's say ICICI Bank, Bandra branch is falling short, it will borrow from some other bank, and it's like taking a loan, right? So I will put an order, all these other banks, who is ready to give me a loan and at what rate? In return they may give RBI bonds in return or whatever. Whoever gives me the best rate, I'll negotiate. So these are what we call negotiated deals. That's why it's called a dealer system. So every day there will be these guys dealing. Now the whole system is set up using MQ. Okay, so there are 4 or 5 dealers in every branch. They will have a standard LAN environment, and then it goes through the wide area network, that's the complete India banking network, until it goes to some common server where people will collect all the orders, they will do a broadcast. It's like a standard matching. Okay. Now in this case what happens is, we are going over a wide area network, and it happens, may not happen every day, every second, but occasionally or sometimes quite often, there will be perturbation where the links go down. Sometimes even a ping may take 30 seconds in those intervals. Okay. Now when this happens, your MQ channels go down. So MQ will normally give you a facility where I can retry and says, okay, let me retry building the channel up to 3 times, and my time between retry is, let's say, 30 seconds or whatever. After which it will give up by saying that I have tried my best, I cannot establish connectivity. Now the challenge that is faced with the CCIL is, all of these guys say, the dealers, is that if we get logged out of the system, you must cancel all our pending orders. Why? Because somebody else, they want to go as per international standards. Okay. So internationally it's a claim practice, I get logged out, my orders should be cancelled. Now think of it, all the orders at the host end, I don't have a direct connection to the host end. I am at the dealer workstation, my orders have to be cancelled. How is the host end supposed to know that I have got logged out? Correct. So this becomes a big challenge for us. Now, if I want to know, then the host and the dealer workstation must have some state, and both should be in the same state where they understand each other. Now, how do we introduce that? Okay, so one way is, I can say I'll call you up, and you set up a help desk. Okay, I have got logged out, cancel my orders. That's a very painful and laborious process. Correct. So other ways, what we do is we build a very simple self-healing system, where we say, in addition to normal traffic, we send dummy requests like a heartbeat. So every dealer will have a dummy request that keeps going around the network, and we say, okay, my round trip time is, let's say, 30 seconds or some seconds. If the host end does not get this dummy request from the dealer in so much time, they will assume that something has a fault in between. Whether the MQ channel has gone down, or the LAN has gone down, the server has gone down, we don't know. But something has gone wrong, you cancel the orders. And then in that case, the moment they detect the heartbeat is not reached, automatically at each end, it's a distributed state, right? So everybody monitors the heartbeat, and everybody then checks, what should I do to initiate recovery? So this guy will keep trying to build up the MQ channel, this guy will keep trying to build his end, and then everything assembles by itself automatically. There is no manual intervention required at all. Okay. So this is the kind of stuff which is very simple self-healing, but the amount of downtime it saves, the amount of responsiveness it gives is tremendous.
So, generally a host end will oppose to the other
See, it is a message. Let's say I am a dealer, you are the host. Okay. So there is no polling. I send you a message, you send it back to me. It keeps circulating around and around. Correct. So I have not got a message in the last, let's say 2 times, whatever you decide on some round trip time, okay, some threshold. I have not got a message for you in the last half minute. I will assume I cannot reach you, there is something wrong, and I will initiate recovery at my end. You have not got a message from me in so much time, I will say okay, I am assuming you are down, I will cancel your orders, initiate whatever recovery I need to do, correct?
Yeah, message is initiated by the bank not by the host, right?
It's like
it is just circulating, right?
Going round perpetually. It's a dummy
So
message.
it is, when you say initiate, see, it's not a request response. I keep circulating the token continuously. So everybody knows whether you got a certain token or not per user, correct? So it's, yeah, I mean you have to decide this timing is important and number of dealers is important to decide how much you are overloading the system. But normally, we are talking of timing in half a minute, 1 minute duration. So it's very little load on the system because of that, correct? So that's, pretty much what I had. There's other thing I'll, give it in the slide. Maybe I can add few slides on this. The other part which I thought is slightly advanced, but it's useful to know in the context of analysis. Okay, as I said, I'll not get into mathematics. I'll just show the slide and you can work it out as an exercise. These are cases which say, okay, everybody deals with service-oriented architectures or services. But now we also have services which have a lot of mobility. So services we migrate. A simple thing is, let's say I change my location, some DNS server needs to know about my IP address or whatever. There could be many situations where a service has to migrate. Now how do I locate a service? Okay. So one standard way to locate a service is, there is some central site which maintains a registry of all services. So first is I go and contact it, could be a name server, could be whatever. I get the location and then I invoke the service. Okay. So this is done perpetually. So it's a standard 2-step process to invoke a service. The other approach is, so that means whenever a service migrates, a service will notify this registry or this directory that I have migrated, here is my new location, correct? The other approach is, let's say I change my phone number, what do? There is a forwarding address, correct? So if I call your number, you will say, okay, ये number पे मौजूद नहीं है, ये number dial करिए, correct? So that means I store my next address at my previous location. And whenever I migrate, I have to keep doing it. That means anybody wants to reach me will go through the chain of forwarding addresses until they finally get to me and then cache the new entry, correct? Now given these schemes, normally what do you do, okay? If you have to analyze these things, the normal way in which it works is, because of past experience, topology, wherever you come from, there will always be a bias, okay? Some people want the centralized approach and some people want the distributed approach. So people who want the centralized approach will say, okay, see, it's always giving me a guarantee, the worst case in this case can be so bad and so on and so forth. And the person who wants this approach will say, see, the best case it is one lookup, here always have to go for 2 lookups. And this is what we call hand waving. Okay, so hand waving means whatever answer you feel it is right, and you will try to convince somebody in various kinds of arguments that it is right. If you say quantitatively analyze this, how do you do it? The standard way is build a simulator, build a prototype, do something, and then say, okay, which is the best way, okay? Now, we will not go into techniques, but if you know some techniques for quantitative analysis, like there is something called Markov chains, you can do a very simple analysis of this and then figure out what should be the right approach to choose for the average case, okay? So the centralized case, I always need 2 lookups, okay? That is fixed. In the distributed case where I am doing the forwarding address, the number of hops I have to make from the client to the final server is given by this, okay? Where what is this term? This lambda is the rate at which I am running away from you. Okay, let's say you keep changing your number every 10 days. So that's the rate at which I run away from you. And mu is the rate at which I am running after you, I am calling you. Okay, which is a simple case, which means is that if my rate of going away from you is more than the rate at which I call you, naturally you are going to be far off. But if I call you very often, you are going to be very close to me. Correct? And that's most of the time. Most of the time services, the invocation rate is going to be much higher than the migration rate. Which means quantitatively we can tell you that this distributed case is going to be much better on the average than the centralized case. Okay. Now this is based on actual quantitative analysis. There is no hand waving and all that for it. Now if you want the actual analysis, there's whole thing on Markov chains, we'll not get so much into it, but I'll just tell you what happens in Markov chains. First is you draw the first case is easy, right? Centralized best case, average case, worst case is 2 hops. Distributed case, I have to first create a state of the system. State of my system is how far is the service from the client. So either I'm 0 means I'm actually knowing a current address, or I migrate 1 away from you, 2 away from, this is the number of hops I'm away from you. Then what you do is you form the arcs. So first is you create a state transition diagram by saying is okay, whenever I migrate away from you, I will increase my hop count by 1. Now whenever I actually access you from 1, my hop count comes to 0 because I know a recent address, okay. So if I'm at state 2, where will I go to? I go to state 0 because I'm always getting a recent address, okay. So this becomes a state transition diagram. Now against the state transition diagram, you put these rates. At what rate am I migrating away from you? That is what we call as lambda. And what rate am I pulling you? I call it mu. Okay. And then you start solving simple equations, which means that at every state, my rate of departure has to be equal to my rate of arrival if I have to be in steady state. You solve the equations, you can work out the math. This is what the answer you'll get, 1 plus lambda over mu, and then you can analyze. So these are things, okay, there are assumptions, we'll not get into the technicals of it. But the nice thing very often in simple Markov chains is you get a nice closed form equation, which then you can analyze. And if it matches your intuition, nothing like it, okay. That is much better than the hand waving approach, because hand waving always is looking at one side of things, correct. So I'll close here. Any questions? If no questions, then we'll assume everybody is understood very well, we'll have an exam.
Sir,
Good.
which is the website available on which we will get perfect time to time stock rates?
See, the closest you can go is go to the exchange. Okay. So exchange has its own website. You can go to NAC.com, you will get always up-to-date stuff. If you are in US and all, other markets, India you will get all this. Each of the websites is, NAC will give you its own site, right? So there will be other ones, which I am not a stock exchange specialist, but there will be other people who aggregate across all exchanges. So as Dr. Phatak said, Reuters could be there, many others will be there.
Right. Suppose sir, we are using some type of this ICICdirect.com, and suppose we have given one order and some order has been, they have given also order number, but still the order has not been executed. So can we put case on them or?
You cannot put. See, you are dealing with a brokerage, correct?
Already sir, we have given order.
I know, but
that rate has come, still our order has not been executed.
You have given order to the brokerage.
you are working with you are interfacing with a brokerage firm, okay? Not with the exchange. As an internet trader, you cannot access the exchange. Brokerage firm is only acting as a router. And the brokerage firm takes a liability for all orders it sends to the exchange. Correct?
But sir, suppose I have given order to buy suppose 500 rupees or
correct.
500 rupees of this ICICI share.
You get a confirmation. Order confirmation just says I've accepted your order is valid.
Order already they have given the code.
It is even that code.
I have sent to the brokerage.
Correct.
May I suggest we take this question outside,
yes,
because this does not pertain
to performance.
performance.
We can discuss that, not after this, okay?
Sir, there are certain mission critical applications.
Correct.
Like exam results, whose utility is only for 2-3 hours.
Correct.
Say CBSE exams, where millions of hits happen and 2-3 hours student get the result. Such kind of application performance play a very key role.
Yes.
And do you have any suggestion on that? Because they are fetching giving the roll number on the side and they are getting the result.
Correct, but first we look at the rate. See, when all the examples I've covered, State Bank of India, NAC, these are ones where you have pretty much the highest rate of processing. So you will typically in NAC, we are dealing with almost 20 million transactions per day and just about 8 CPUs, correct? If you deal with State Bank of India, you are dealing with close to 20 million transactions per day. Now, all of what I have spoken about, the same principles apply to any system, correct?
Because here billions transaction in 1 hour or 2 hours.
Billion transactions come on there. I mean, you may have 5 million, 10 million.
There are no
Okay.
billion people.
Correct.
But students, they are
No, there are not 1 billion people.
Even student result, okay? Even you take 1 million, 2 million, even 1 million per hour. Here we are dealing with exchanges, also exchanges, you will have 25% of the load. Okay, take 20 million transactions. 25% of the load occurs in 30 minutes. So we are talking of 5 million plus transactions in 30 minutes.
But Rajesh, let me answer this. The point is that when Stock Exchange or State Bank of India puts a system in place, let me mention it in terms of capacity.
Correct.
When they provide a capacity, they do this analysis and they build a capacity. Typically what happens in the examples that you gave, most government related situation, the capacity is never planned for the peak load. So usually you put some Lallu server there which will appear to work during the year when nothing is happening, 1 or 2 responsive requests, and suddenly you get million requests. There is no reason to blame that server or whatever. This capacity planning is, in fact, that's what I have always stated, that in your system analysis and design, performance is not a mandatory parameter to be taken into account. And this is the biggest problem that I have. Performance, I mean the terms that I had used to his own colleagues in TCS when they architect a solution and give, I say that you architect a solution in isolation, you set it up, you develop the system, and when you start running it, you all then run to Dr. Pansharama and solve that problem. So if you had run to him to begin with, probably this fire would not have happened. So my suggestion is that whenever you do simple Fatak's tableau, no system analysis is considered complete unless there are at least 3 pages of this plain back of the envelope calculation where you have asked the end user what are your normal load, what is your peak load, what is the response time that you want, how many users are expected to hit that system. Without this data, if you do system analysis, what happens is we spend enormous time in writing down functionality. This validation should be done like that, this screen should look like this report should look like this. But nobody either asks a question or nobody says how many users are likely to be. If a government department, if a board tells you that there are going to be so many users this, you would have taken that upfront while calculating capacity. And if they tell you wrong, then you can always tell them that look, the capacity planning is based on this judgment or based on this plan.
One thing that I would like to add to this is that the particular situation that you mentioned has a tremendous variation between the peak and your normal.
Yeah.
I mean, it's like, probably 300 days in a year there is zero load on the system.
Yes.
And now 3 days a year there is like tremendous load on the
The standard deviation.
Correct. Yeah, but the planning always has to be done for that peak situation. I mean, you may rent out capacity for that week, that's okay.
I think
Correct.
one of the things that we could do is that, probably the CBSE board will not maintain infrastructure like the NSE would have to do, because on a day-to-day basis they have peaks, right, which they have to handle every day. So they will invest in a lot of infrastructure that they're going to maintain and run. But this notion of virtualization, I thought, will bring into play, where you'll possibly be sharing infrastructure with somebody else who will also be generating a lot of load onto the system.
But at different times.
At different
Time.
And so this period of the year where results are announced, you will probably be given priority over this infrastructure and then somebody else. That's probably how this will work out best for you.
Which are the other emulators rather than VANET?
Well, see, there are several. Most important, as I said, one is for the network. Okay. Second is for databases. Now that we have not released to open source, but we do provide to customers. So that is saying how can you emulate the delays of a database based on certain properties. So I will make it appear as if the volumes are bigger. So sometimes people call them responders also. And the other is we also need to sometimes work on the interfaces. Okay. So let's say my system works fine, but then I need a feed that is coming in from the outside at this rate. So those are what we call as stubs, which very often you will build, which may be dependent on functionality, whereas a database and random are pretty generic. Okay. The other one you do sometimes is also on the workload. So you are dealing with single user development, you want to introduce a background workload. So that's what we call a workload emulator. So these are standard things that are set up. Okay.
And there are commercial products also available which will aid generating some kind of load.
See, commercial you generate load is when you are doing the testing part of things. So that is, you will have all your load runner, rational, many of these tools. Okay. But during development you want to sort of create a background things. So normally what we do is we have some of the simple capacity planning models It's a single user, this much should be the time, multi-user so much the time, and then you slow it down by putting a sleep or whatever in between.
So all this performance analysis has been done without keeping in mind what technology we are using, like for programming and all. If we just try to introduce the concept of service-oriented architecture in this, then what is that performance evaluation will do?
Let's see, many of these terms we spoke about, right? So you may say, okay, like this last one we spoke about, there will be much of the analysis, be it in service time, access rate, all of these will, the timings will get depend on the technology. But the principle of analysis all remains the same, correct? So let's say I say there is a demand on a given resource. Now visit count will remain the same no matter what technology I use, because architecture, but service time will depend on the technology. So normally what you do is you take measurements based on the technology, find out the service time and then plug it into the model you are dealing with.
One of the examples that he gave was the amount of time that it takes for a SOAP message to go through the gateway, right?
Correct.
So that would be a service time that you plug into doing analysis of the gateway itself. Things like that.
So in fact,
Techniques are generic.
the point
Yes.
is that SOAP, .NET, plain TCP/IP. Plain TCP/IP is the fastest. But if you need the kind of abstraction that, let's say, service-oriented architecture provides, not comfortable using plain TCP/IP or use SOAP, then you have to live with that service type. There is no shortcut. The shortcut is, as he suggested, look for partitioning there. Instead of putting a file, a simple example that I give is that you're familiar with XML, right? Very popular these days. You exchange even transactions are to be sent using XML. Basically, what is XML? You are basically sending metadata and data together in a format which is very bulky. The amount of information that you have to spend is too heavy. So if I am sending individual transactions for processing, it makes sense to send metadata and data because there is no other. But suppose I want to transfer a file with 20,000 records. Now imagine I take every record, convert it into an XML record, send it, take the second record. Please note that the XML description of the second record is going to be exactly identical. So what I am doing is I am taking actually a fixed payload which I have to transmit, namely information contained in these 10,000 records in the old classical record file notion. But because now the data is in database, I extract one row from a table, convert it into XML, make it fat, send it. There he makes it thinner because he has to insert it in the database again. Would it not be much better to say that I will transfer the metadata alone using an XML record and say that I will put a flag with date or something like that, that any record which comes subsequently with this flag as a tag is to be interpreted in terms of that XML metadata. So I send just the metadata by one record, extract it there, keep that metadata information alive as long as I get this record. Why? I can make 10 times things faster.
See, the other way that you can deal with performance issues is, Rajesh mentioned the pipelining approach, right? So you can pipeline software servers themselves. If you take a SOAP server, part of what the SOAP server does is to deal with headers, right? And then it would deal with the body of the message. So you can pipeline those two aspects of it within the software server. So there are standard architectures called SOA architectures that deal with this kind of pipeline. It allows you to pipeline, it's called event-driven architecture, which will help overcome some of the performance issues that you'll see with SOAP processing over.
And you also get, accelerators. So you'll get XML accelerators, which will do some amount of your routing, some amount of parsing. Okay, so there is a lot of stuff which is there, which is technology specific. So, but still, the principles of analysis, that you still will be constant. Correct. So that you must always have, which is the generic principles of analysis. Always keep that in mind. Then you may take a technology, you may measure it, you may apply it, and then say, okay, what benefits can I get? Correct.
In fact, I would say that its strategy of dealing with the MCA project, where you are filing things, is an extreme example of the suggestion that I am making. He is not even transferring even a single record. He is transferring a file name and says this file name contains both the metadata and data. Look at it.
Correct.
Your problem is
Yeah.
I have one doubt about this. So when we go for analyzing an existing application, I mean existing or new applications,
Correct.
So this technology specific questions, like how much time soap takes. So is this the approach we are going to follow, that we are going to create an abstract model of my application, saying this is my application is going to need 10 database access or a couple of web service access, and then calculate the business time?
Yeah, so what we are doing right now, some of the new things we are doing in research, you see, the technology may keep changing, whether it is service oriented or even database will go to Oracle 11, whatever. So you say, okay, on any technology, finally your application is invoking some operation, your workload. Business workload will transfer into an operational profile for that technology. So you'll have a certain primitives. Like a database, you'll say, okay, I can have DML statements, I can have select statements, I can have whatever, correct? So you can have a SOAP request of this type, whatever. So you say these are primitives that are possible in the technology. Each primitive has to be calibrated, and you create a primitive model that what is the cost for an individual operation. Now then you have to translate your business workload into a technology workload, and then convert it into a technology cost, and then say, is it going to be sufficient, and is response time I am meeting certain SLAs, or for capacity purposes how much capacity I need to invest. So that's a standard thing we do without having to be too hardwired into the technology, correct?
So one of the active area officers, as well as a lot of papers have been published in the area of taking, for example, a UML message sequence diagram and translating that to a queuing model. Of course, with some, if you have a UML 2.0 profile, which will allow you to specify certain additional performance profile data. So, for example, a message sequence diagram might actually hit a database. It's part of your MS.
Yes, recorded.
Okay, so if that happens, then whatever this tool is, Speed is one such tool that's commercially available, can let's take this and translate this to a complete queuing model, quantitative queuing model, which can then be solved with various means. So there are commercial tools available which will do this for you, as well as, I guess, Workda has created one open source tool, which will, you have to do the modeling by hand, but then it will solve that.
See, the other thing we also do sometimes is, depends on how much time you are available for the calibration, right? So one option you say is, okay, there are vendors who publish industry standard benchmarks. So you can go to a TPC site, you can go to a spec site, and you'll say, okay, the spec rating of this box is so much if you're using this application server, if you're using this Java version or whatever. Now you have to be able to take your transaction complexity and map it into a TPC or a spec transaction complexity. So some of it, we do based on primitives, some of it we have what we call magic numbers, which comes after some test and experiment, and then it becomes a simple model to apply. Okay. So these are standard ways you deal with it. Because if you single-handedly want to cover all technologies, there is just too much of it, the way things are changing.
One of the biggest problems that I have faced always is how do you map the business functionality into these kind of primitives.
Correct.
So it's not very easy, generally to say so many queries of typical software engineering is simple, medium, complex. That doesn't work out. Worse, the way you implement your software, develop your software, write your software, is often, it makes a major difference in the performance. My own personal opinion, and to date it has not changed because I have not found evidence to contrary, is that whenever you are getting a performance problem and you are asked to tune it, typically the tuning happens at the database level where you try to reset parameters at the operating system level, etc. But 90% of the problems are caused by bad programming at the application level. And that happens again, my favorite point, is because performance is not factored into design and development. If the developers and designers, every 10 days, they ask themselves a question that whatever work I have done for 10 days, how does it measure on a possible performance problem? Then these problems will not occur.
Correct. In fact, I had a slide, I sort of removed it because lack of time, was if I give you an end-to-end target, 2 seconds, so much throughput, so much capacity, how do you translate into targets for developers?
Yes.
Correct. Which means if you're taking, let's say, service time, how do you get it service time target? Okay. So I'll just give a simple example, maybe that will be clear. Okay, suppose I say here I have 3000 users. Okay, here's my users. Here I have, let's say, an application server. Here I have some database server. Okay. Let us take a simple example, right? So I am making one transaction only has one HTTP request here, maybe it has 5 SQL requests here, comes back. Let's take, end-to-end response time of 2 seconds, think time of, let's say, 28 seconds. Clear? Now you say, okay, if I have this requirement, my throughput, you know little law, right? So this becomes 100 per second. That means we said my demand, we are looking at if I have to achieve a throughput of 100 per second, my demand has to be less than 10 milliseconds. Because 1 over the throughput that I can get. Now you say what is the demand? That is my visit count times my service time. Correct? So let's say, okay, I have 12 CPUs at the application server. Let's say I have 20 CPUs at database server. That's also given. Now if I say at my HTTP request, I can go to any of the 12 CPUs. For the HTTP server, my visit count is 1/12. This is my service time. This has to be less than 10 milliseconds. That means at the application tier, my service time has to be less than 120 milliseconds. Same thing with the database tier. If I say I am giving you 5 SQLs, each can go to any of the 20 CPUs. That means on the average at the database tier, my service time has to be less than 40 milliseconds. Once you give a target, then you have to measure against it. If the target was not given, then what's going to happen? Sometime during testing you will have an end-to-end picture and you will not know where to get. Then you start tuning, tweaking and trying to grope in the dark and never getting anywhere. Okay. So these are standard ways, very simple things which you can apply just to translate down to targets. And that is a must because as I said earlier, nowadays at least people are so smart that given a target they will find 100 ways of achieving it. But if a target is not given, they will always say it's somebody else's problem. Correct? That's how it is.